January 20th, 2014. Andrea Akamatsu commutes to the European Space Agency, unaware that the Rosetta space probe he has piloted for 10 years is about to make history. Within 6 months, Rosetta would reach its objective, the comet 67P. This event would crown centuries of scientific research into mankind's place in the universe. How did life begin? Has life emerged elsewhere? Questions that inspired one of the most ambitious missions ever in space exploration. This evening, Andrea Akamatsu's team is waiting for the Rosetta probe to re-establish contact after 3 years of silence. In 2004, Rosetta left Earth on a 6 billion kilometer odyssey, carrying the work of thousands of engineers and 2 generations of scientific endeavor. However, 7 years into the voyage, and at more than 700 million kilometers from the Sun, the energy produced by Rosetta's solar panels became insufficient to maintain the systems in standby, forcing Andrea Akamatsu to initiate a high-risk procedure, the switch-off of all electrical systems, leaving Rosetta shooting through the solar system out of contact with the flight director. This morning, if everything has gone as planned, an internal clock should have reactivated Rosetta's instrumentation and oriented the antenna towards Earth. Meanwhile, in California and in Australia, 2 ultra-sensitive antennas are oriented in the presumed direction of Rosetta in the hope of picking up a signal. Communication should be established by 6 p.m.
The signal we'll see coming up on those screens, we have a spectrum analyzer, so something that measuring noise. Fundamentally, we'll see a lot of noise, and when the signal comes, we'll see a vertical line.
In the ESA press room, scientists involved in the Rosetta project are present for one of the most critical phases of a mission first conceived over 20 years ago. The ultimate goal of Rosetta is to approach a comet at an altitude of a few kilometers, to travel with it over several months, and to deploy a robotic lander, Philae, on the surface to analyze its composition. A composition that may have been preserved intact since the birth of the solar system.
The key is in the mission name, Rosetta, as in the Rosetta Stone. We hope and we can be reasonably confident of success to both gain an understanding of the origins of the solar system and perhaps even comprehend how life first appeared on Earth.
As the signal from Rosetta has not yet appeared on screen, the scientists are faced with the realization that all of their hopes depend on the startup of a computer that has been powered down for 32 months in the cold of space. Jean-Pierre Bibring is a charismatic personality of the Rosetta mission. Ever present since the beginning, he directed the conception of the Philae lander, the module that must land on the comet.
All space missions involve great risk. This is because a good mission is a mission that tries to combine scientific ambition with technological challenge. Consequently, we are always operating somewhere on the extreme limits of what we know how to do. If the reactivation fails today, there's nothing more we can do.
Contact with the probe is re-established, but for the pilot, Andrea Akamatsu, the most delicate phases of the operation have just begun. Locate Comet 67P, an object just a few kilometers long, hurtling through the depths of the solar system. direct the Rosetta probe towards it, and land a laboratory designed to elucidate the origins of life.
All that we do with Rosetta is to try to understand the specifics that enabled life to emerge, at least on Earth, to attempt to understand if the process is generic, and if that process type is sufficiently generic to occur elsewhere in the solar system, or even elsewhere in our galactic environment. So this type of research is an extension of something that is deeply rooted in mankind's universal interrogation.
We now know that at the instant of the formation of the solar system, billions of debris fragments were ejected at great distances from the Sun. Far from the solar heat, they would have remained intact and may contain precious clues for our comprehension of the evolution of matter into the first life forms. This matter gravitates in an orbit far beyond Pluto that currently remains unattainable. However, debris fragments are sometimes accidentally caught in the inner solar system and thus fall within the reach of scientists eager to probe their secrets.
As they approach the Sun, close enough for the ice to begin to sublimate, they become engulfed in an enormous comet trail that may stretch for millions of kilometers, even though the comet nucleus itself may only be a few kilometers long. At this time, they may lose several meters of surface material. On an object that is only a few kilometers long, it means that it may only complete just a few hundred orbits before ceasing to exist.
We call these objects consisting of ice and primitive matter comets. This is Ison, filmed by the Soho Observatory.
When you see a comet, you are seeing the comet's swan song. A comet is nearing the end of its life.
The idea for the Rosetta mission came about following the most recent near-Earth pass of Halley's Comet, a space object whose appearance every 76 years has influenced the evolution of mankind's thoughts on the universe. When in 1759, in accordance with Newton's stated laws and the predictions of his colleague Edmund Halley, a comet did indeed appear in the terrestrial sky, universal gravity was definitively validated. This same force regulates the movements of all celestial objects, a force that accounts for the orbits of the moon, the planets, and of comets, just as it allows the movements of an apple drawn to the ground to be calculated.
In the 18th century, an enormous number of remarkable achievements were based on this acceptance of universal laws. The same laws could apply to the movements of both an apple and the moon, and indeed at any scale, objects obey the same laws. The cosmos thus became the universe. It is universal, meaning everywhere at all levels the same laws operate.
By the end of the 20th century, to Newton's laws could be added technical mastery in space propulsion. Now mankind could place artificial satellites in orbit around the Earth and tackle interplanetary exploration. In 1986, as Halley's Comet again approached Earth, we were able for the first time to fly out to meet it in a series of missions that would inspire Rosetta.
5 spatial probes were launched for the encounter in an attempt to understand the nature of the comet nucleus.
Obviously, we had never before examined these small objects. They were thought of as white snowballs.
Those missions were among the most spectacular that we could have conceived.
2 Soviet probes, 2 Japanese probes, and a European probe called Giotto were launched for the encounter with Halley's Comet. Jean-Pierre Bebring worked on the measurement instruments of the Soviet Vega probes that would be the first to cross the comet's trajectory. Annie Chantal Levasseur-Regour was involved with Giotto, which became known as the Kamikaze mission.
It was the first time we could observe a comet nucleus.
Giotto approaches to 600 kilometers from the comet nucleus. As it expels gases, the camera is destroyed, but it had already been able to transmit the decisive data. And this time, Halley's Comet caused us to reconsider our ideas on the emergence of life on Earth.
The first absolutely incredible result found, and nobody could understand it, is that the comet is the darkest object that exists in the solar system. It is darker than coal, but it consists of ice. How is it that this ice could be so absorbent, so dark?
The darkness of comets may be due to the presence of carbon molecules in a form far more evolved than was previously imagined. Organic molecules, perhaps even amino acids, the basic building blocks of life that may have remained trapped inside comets before seeding the Earth.
It is highly possible that these comets may have carried complex carbon molecules that, through processes that are not completely understood, and that are certainly extremely complicated, gave rise to life on Earth.
However, for these missions, the instruments carried aboard were not suited to the analysis of organic molecules. All of the international space agencies then began to imagine new comet exploration missions. In 1993, the most audacious of these was presented to the media by the European Space Agency, the Rosetta mission.
Le 30 juillet 2005, Rosetta se posera sur le noyau de la comète.
Rosetta is the mission equipped with a laboratory capable of analyzing on-site the nature of a comet. We want to know the makeup of the initial material from which it appears. From the seeding of the terrestrial oceans, life was able to emerge.
Thousands of scientists and engineers were asked to imagine an automated spatial laboratory capable of dissecting matter from a comet. On the orbiter, Rosetta, a particle accelerator that must recover dust from the comet and analyze its composition. A spectrometer capable of determining if water from comets is of the same nature as terrestrial water. And high-definition cameras that must aid navigation and read the site topography with a view to landing. On the lander, Philae, 7 cameras that should provide the first ever panoramic view of a comet, a radiographic apparatus to determine internal composition, and the COSAC system that must drill on the surface and heat up the recovered samples in miniature ovens in the search for organic molecules. In total, the probe is equipped with 22 analytic tools. It would also be necessary to invent all of the navigation equipment, communication systems operating at distances of several 100 million kilometers, 30-meter-wide solar panels to provide power for over 10 years. An ejection system that must propel the lander at an exact speed, batteries that must function at minus 150 degrees, and harpoons that should propel themselves automatically to anchor on the surface of the comet. In 2002, ESA cameras render immortal the Rosetta Spatial Laboratory and its Philae lander seen here on the left flank just prior to the space launch.
A mission of this type is the work of a lifetime. The assembly of the instrumentation took 5 years, and the probe's voyage another 10 years. Then within a 2-hour period, we will discover if the last 15 years have been a waste of time or a triumph. So yes, it is entirely possible that after 15 years we might have to admit, okay, it's not working. We have nothing.
Das ist 200 milliamps, 1 volt. Das ist ein Fünftel Watt. Ja, es geht.
Fred Gosman manages the COSAC system. He himself designed the miniature ovens intended to heat up the comet samples for residual gas analysis, and hopes to identify traces of organic molecules, maybe even amino acids, the elementary building blocks of life.
If we could certify that there are in fact molecules on the comet that could give rise to life, if they were to fall into the right conditions, somewhere with water or an atmosphere, wouldn't that be wonderful?
A few weeks prior to the scheduled arrival of the probe at its destination, Fred Gossman is practicing transmitting commands to the spatial laboratory using a land-based replica of the lander instrument. His colleague Martin Hilkenbach, in charge of the particle accelerator aboard Rosetta, is similarly occupied. They try to anticipate every eventuality to best analyze the comet's organic material and perhaps unravel the mystery of life.
When we search for signs of life, it's always life as we know it on Earth. Life as we understand it is based on organic chemistry. We know no other form of life.
Life emerged on Earth about 3.5 billion years ago from a complex assembly of organic molecules. Today, at the beginning of the 21st century, though capable of launching a spatial laboratory into the far reaches of the solar system, we remain incapable of creating the simplest form of living organism.
When you address the questions of the origin of life, you are probably confronting one of the last myths to remain intact.
Louis Dendecourt is an astrochemist. He is trying to recreate life in a laboratory by imitating the conditions that existed at the beginning of the solar system.
We can define a system in which there is certainly water that is not too hot, large molecules that are necessarily very stable, and for bonding to occur between chemicals that are capable of reacting with each other, energy is required. And basically, this energy could only be photons from the sun.
Astrochemists like Louis Dendecourt attempt to understand how primitive matter from the solar system gradually transformed into life.
All of the elements present here on Earth, and all of the elements of which we are constituted, and by this I mean atomic elements, all of this we know is formulated in the stars. So there is no mystery. There is a very strong link between the stars, the planets, and ourselves.
Today we have a good understanding of how the first forms of terrestrial life progressively evolved into the present diversity such as plants, mollusks, dogs, humans. However, what happened just prior to this process getting underway remains a great enigma. Louis Dendecourt focuses his research on this transition from inert matter to living matter.
We are trying to answer a series of very disturbing questions. Why are we here? Where are we going? For me, there is no dilemma. We are here because we are children of the cosmos. We are part of the evolution of the universe.
But what led to matter attaining life? Just as biologists have been able to reconstitute evolution using fossil remains, so astrochemists hope that space exploration will provide molecules that have remained intact for billions of years. The comet 67P, discovered by Churyumov and Gerasimenko in 1969, is the target of mission Rosetta, the most complete experiment ever envisaged to understand the origins of life. In March 2004, a new version of Ariane 5 prepares for launch with Rosetta aboard. At the same time, in Darmstadt, Andrea Akamadzo, then 34 years old, prepares to take command of the probe. At the instant when Ariane releases Rosetta, the control of the craft will be his.
On the 2nd of March 2004, Ariane 5 took off from Kourou with Rosetta on board, and this was fantastic. It's a big relief. When it takes off, there is this big bang coming from the Ariane. But a few seconds later, you realize that there's still a long way to go up and to have the spacecraft successfully separated. And these were very, very long hours.
Two hours and 13 minutes after liftoff, according to the time-honored expression, all systems are go. The Arianespace mission has ended. That of Andrea Akamatsu has just begun. It will last 12 years.
Here on this drawing, that the sun is in the middle of the solar system, well, the orbit of the comet around the sun looks something like this, so relatively wide. This is the comet, where the comet is flying around the sun. If I take the orbit of the Earth, which is our starting point, well, it's something that looks like this. This is the Earth. So you see, the orbit of the comet is much bigger than the one of the Earth around the sun. And what the Ariane 5 launch vehicle could give us at launch, well, it was something only slightly different from the orbit of the Earth around the sun. So we see we are far away from where the comet is. To be able to reach the comet, we use a technique that is known in spaceflight. It's called the planetary swing-by.
Based on the laws established by Newton, a planetary swing-by consists in placing the probe within the gravity field of different planets so as to profit from their movement around the Sun and so accelerate the probe. This is because neither the momentum provided by Ariane or the probe's built-in thrusters that serve merely to adjust trajectory are sufficient to attain the orbit of Comet 67P.
So fundamentally, we used the energy of the planets flying or rotating around the Sun to launch Rosetta farther and further out. It's like a chain that captures Rosetta and launches Rosetta far away.
3 years after its launch, Rosetta enters the gravitational field of Mars to undergo another acceleration.
As it passed close to Mars, we turned on our cameras and caught an image that I'm very fond of, where you can see Mars behind and the probe in the foreground with its huge solar panel. Rosetta passes in front, takes a picture, and then travels onto the comet. Well, there's something very moving in all that.
After gaining from the movement of Mars around the Sun, Rosetta leaves its orbit according to a planned trajectory to plunge towards Earth in November 2007, and then again for the last time in February 2009. After 5 years on a meticulously calculated interplanetary trajectory, the probe leaves Earth definitively now, with the necessary speed to place itself in the orbit of 67P and join it at the farthest point from the Sun.
In the course of the interplanetary flight of Rosetta, we had the chance to cross the asteroid belt twice. And we had the scientists in the control room with us. We were downlinking in real time the data from Rosetta, and they were producing images for us directly on their laptops there. The first image that struck me was we were approaching the asteroid, we could see the asteroid far away from us, and there was a small star behind it. By looking carefully at the pictures, we realized that the star was Saturn. We could see the rings of Saturn. This was fantastic.
8 June 2011, while its momentum propels it towards the orbit of 67P, the Rosetta probe systems, now too far from the Sun to function, are powered down. There will be no further communication with Earth for 32 months. During the voyage of Rosetta, the scientific teams keep track of the progress of other space agencies, with both the interest and anxiety of competitors. NASA's spatial probe Deep Impact fires a projectile from a distance of 8,000 kilometers into the nucleus of the comet Tempel 1. The impact is filmed by several probes and telescopes. Then the Stardust probe. After traversing a comet trail with a relative velocity of 20,000 kilometers an hour, returns to Earth with some comet dust aboard. A NASA laboratory affirms having identified traces of glycine, an amino acid present in all living things. But the small quantity of molecules recovered and their degraded state due to a violent impact mean that it cannot be established with certitude that these organic traces are definitely from the comet and are not due to terrestrial contamination. In 2014, the Rosetta mission remains on track to accomplish an unprecedented exploit.
We more or less know perfectly where Rosetta is. We know less perfectly or less well where the comet is.
Since the reactivation of Rosetta, Andrea Akamatsu can again interact with the probe. But at this stage of the mission, the position of the comet, deduced from terrestrial observations, is too imprecise to attempt to fly over.
We want to fly Rosetta down to a few kilometers from the surface of the comet. Before approaching the comet, we have an uncertainty on the position of the comet on the orbit of 10,000 kilometers. And it's clear that these two things don't match together. We have to resolve this, and this we can only do during the approach phase by taking optical images.
Visual navigation will only be possible after the cameras aboard Rosetta begin to detect light reflected by the comet. At the Max Planck Institute, Holger Sirks, responsible for the two high-resolution cameras aboard Rosetta, is searching for the first visual indications of the comet.
These images are authentic, unprocessed, with cosmic rays. They are, in fact, in the state that they were transmitted to us from the spatial probe.
The fixed background of stars serves as a reference in space. Here, this constellation, identified on a reference image, is superimposed over the same constellation photographed by the Rosetta camera. All celestial objects are aligned. And at the presumed position of the comet, Holger Sirks looks for a new luminous point, the trace signature of 67P. And then one day, speculation becomes certitude. This point at the center that's moving, it is the first tangible proof that 67P is in the line of sight. Holger Sirks sends the image to the rest of the team.
We received an email and we knew exactly what to expect. One dot in a black sky with thousands of white dots. I thought back to the 17 years passed by. The first day you see a picture like this, you say, well, we are making it for real, we are getting there, and this is the comet we are going to. It's not a simulation, it's the real one.
Objective of the flight directors: don't let go of this point in space. Go directly to it. 21 May 2014, the team of Andrea Akamatsu calculates the final modification of Rosetta's trajectory in the hope of reaching the comet. A command is transmitted to activate the thrusters for 7 hours and 35 minutes. If the calculations are correct, the images sent by Rosetta day after day should finally reveal the form of an object that until now has only ever appeared as a bright spot in space.
What I find extremely fascinating in thinking back of Rosetta is the fact that some people, maybe centuries ago, were able, even though they didn't have the technical and the technological capabilities to do something that we are doing now, they were capable of computing trajectory, orbits of planets, of moons, of comets. I hope what we are doing now is felt by these people as an accomplishment of all the studies and the work that they've done.
Every time we receive the first images and see that everything in the field of vision is exactly as predicted, we are relieved. Of course, when we reflect rationally, the laws of physics are relatively well established. It is no surprise that the laws of gravity are verified. But it's always the same. You want to believe it, but when you actually see it, it's even better.
These unprecedented images of a comet nucleus, obtained after a 10-year voyage, are hailed the world over. However, the form of 67P is causing concern. Its right-angled structure and chaotic surface may compromise the most spectacular phase of the Rosetta mission, the first attempted landing on a comet. 23 August 2014, a meeting is organized at the National Space Agency in Toulouse, France, to determine a landing site.
Ça va bien, et toi? Congratulations.
Yeah, congratulations for the everything.
The illumination here, is it really bad?
The flight engineers and the scientists responsible for the Philae lander had 15 days from the arrival of Rosetta at the destination to characterize a comet that until then had been totally unknown. They had to determine its mass in order to calculate the lander drop trajectories, study its rotation and the period in sunlight for each of its sides, and precisely map the terrain to evaluate the risk of rolling over on landing. But initial results evaluations are clear. No site combines all of the hoped-for characteristics. The compromises that are imposed accentuate diverging opinions, particularly between the flight engineers and the scientists.
The flat area of B is more or less the same size of the total areas of the other landing sites where you have mountains and everything. That's why B is good, because it's much bigger than the other.
We told you, for all the reasons that has been said here, that B is not ranked in the top 2. The mission is not only to land, it's to make a science on where we land. The only reason to select a site is your judgment and capability to land on a given area. Of course, it's one of the parameters. The other have to be taken into consideration. That's why we are 70 people in the room and not only flight dynamics in the rooms.
There are sites here that are interesting because we can see the 2 lobes and we can a priori probe both, but they are pretty rough and therein lies the difficulty. But the easiest sites for landing are precisely on the summit here, because there is an enormous crater filled with material that makes it relatively flat. And so it is here that those who are working only on this question of ease of landing would like us to land.
For those responsible for the scientific instruments aboard the Philae lander, the principal issue consists in ensuring that the selected site, if it is to be attained, is suited for the experiments that they designed 15 years previously.
When we got to this comet, within 2 weeks, we are the only ones that are able to project a shape model that is sensible. Yeah. We are the only ones that are able to make computations that make sense. In all these meetings, there's no single one that is able to project a picture with a scale next to that. You don't know whether it's 20 meters or 2 kilometers. Yeah. If we aim for an area that is particularly rough or it contains features of the surface that are risky for the touchdown of the lander, of course we don't consider it ideal because you compromise completely the mission. If you land and flip the lander, then that's it, it's game over.
Scientists are, in a way, dreamers, otherwise they couldn't do their job.
Of course. I would have never decided to fly to a comet.
Exactly. The engineers would never have come up with such a mission.
Personally, I like Site A. I know it's not a very practical spot. It's not so flat. But that's where it's happening. That's where the comet is streaming gases.
During the night, the descent trajectories to each of the presented sites are refined. Eventually, the teams agree on a compromise with Site J, a site that appears to consist of very primitive matter, situated on the summit of the comet, but where the flat surface is not as wide as that hoped for by the flight directors. They have 2 months to establish a lander release strategy.
This very contorted form of the comet complicates our task because here gravity is not constant as with a sphere. This means that trajectories will be extremely convoluted and complicated.
In Toulouse, the CNES team calculates the position from where the Philae lander should be released to attain its target. Philae will be dropped at a height of 22 kilometers, or twice the cruising altitude of an airliner. It will freefall for 7 hours with no controls, but according to a trajectory that depends on its ejection velocity and the gravity of the comet.
It's not an elliptical orbit because it happens in, I think it's only 3 days.
1 month later, it is the turn of Andrea Accomazzo and Vincente companies to establish a flight plan for Rosetta that will take it to the drop point at the correct speed and at time t. But this task is seriously complicated by the distance separating the flight director from the remote-controlled probe. Each command transmitted to Rosetta is received almost half an hour later. Precision, however, is vital. The landing point of Philae depends entirely on the last positioning maneuver of Rosetta.
We have a target point and we estimate relatively high chances to hit the surface within a 500-meter radius. Of course, we hope to be able to do much better than this, but this is the reality we have to face. If we hit a boulder or a slope, even local, of 2-3 meter size, then there's nothing we can do. This we cannot actively control.
In addition to exact calculations, a little bit of luck is required to land and probe the primitive matter of a comet.
Any system left to a certain form of abandon will move towards a spiraling disorder, a disorder that is in some sense mortal. Life, however, is the exact opposite. Life, in fact, builds order from disorder, from chaos.
For a long time, the only possible explanation for the emergence of life was divine intervention or miraculous chance.
If it was just chance, it would be totally impossible. I often use the analogy of taking all the individual parts of a Boeing 747. You throw them into the air and expect them to fall down as a complete Boeing 747. Obviously, it's totally impossible.
Louis Dondecourt hopes to discover the law that explains how matter was organized to kickstart the evolution of life.
Now that we understand, let's say, better and better, the conditions that led to the appearance of life on Earth, I think that within 10 years the problem should be resolved.
This research into the origins of life aims to establish that the appearance of life form stems from a universal law, a logical process of transformation of matter that is triggered everywhere in the universe where there is a conducive environment. A liquid element, such as water, energy, such as the light from a star, and organic molecules, such as those that comets may contain. In 12 hours, Philae must separate from Rosetta in the culmination of a mission that began more than 20 years previously. This, the first ever attempt to land on a comet, has generated intense media speculation. In the control center of the European Space Agency, 1,500 journalists from all over the world prepare to report live as the operations proceed. In a nearby room, Jean-Pierre Bibring and Holger Sirks prepare their teams for the drop sequence. Images from their cameras positioned on Philae and Rosetta will have a crucial role to play in monitoring the operations.
So tomorrow he is in charge of the camera on the orbiter and us on the lander. And so 2 hours after separation, he will photograph us and we will photograph him and we'll put those together. Okay, great.
In the control room, Andrea Agamazzo is isolated from the excitement of the media to concentrate on the most intense 24 hours of his career. But images from the cameras in the room will be transmitted live worldwide. During the night, the separation command is confirmed. At 8:35 a.m. Universal Time, Philae is ejected, but on Earth, this is not yet established. From this point on, Rosetta's role consists in maintaining communications between Philae and Earth. In the Darmstadt control room, Andrea Akamazzo waits for the data confirming the separation to traverse the 28 light minutes, or 500 million kilometers that separate him from the probe. This is the point of no return. Absolutely no interventions are possible before the landing.
We'll land in 6 hours, yes. We're going to get
Klim Churyumov was invited on location to view the landing on the comet that he had discovered half a century earlier. In the ESA reception rooms, the information filtering through is shared. A first piece of bad news is relayed.
The radio works. There's one little negative thing, which is that the thruster doesn't work, but you might remember...
The thruster system that was to push Philae onto the surface of the comet at the moment of impact is not functioning. To anchor onto the surface of the comet, Philae can now rely only on its 2 harpoons that must trigger automatically on contact with the surface. Powerless to influence the descent, the scientists solicited by the media use this time to recall the scientific objectives of the Rosetta mission.
This is an object that can tell us our story.
While on the radio with Annie-Chantal Levasseur-Rigour, Jean-Pierre Bibring receives a message from the Philae team.
I'll take advantage of being on the air to let you know that I have just received the very first image, and we can see our probe. It's in the shade and we can see the light reflected on the instruments outside. And this is very moving because here, for the first time, we are separated from our craft that has carried us for 10 years and we can see it moving farther away from us.
The images transmitted by Rosetta confirm that the 3 legs of Philae are correctly deployed. The Rolex camera, positioned underneath Philae, shows a perfect trajectory.
We can presume that on the comet, the landing has already taken place. But as it takes about half an hour for the electromagnetic waves to reach us, the fact is, we have no idea.
All eyes are fixed on the screen and the face of flight director Andrea Akamazzo. All are awaiting his expression of joy to cheer a historical first. At 5:03 p.m., at the exact time calculated by the flight team, telemetry signals announce that Philae has touched on the surface of the comet.
This is a big step for human civilization.
Congratulations. Welcome.
However, a major problem disrupts the program. 1 minute after his joyous expression had triggered jubilation for millions, Andrea Agamazzo is alarmed by some new information.
It's the redundant one. The nominal one is
nominal is 1385.
Okay, this one is not going down though.
The elevation did not go down.
It's the same
by the way,
resolution
but
as-
it's probably due to the 4 minutes polling.
Das ist ein Tag der Begeisterung, des Glücks und der Faszination.
How exciting! How unbelievable!
The illumination measurements for Philae's solar panels indicate that the lander is not stabilized. Philae's situation is uncertain. Two hours after impact, we are still awaiting the promised image, the foot of a laboratory planted on a comet. But this tangible proof of a landing does not arrive.
The only thing which is certain, it has reached the nucleus.
We don't know if it stayed there.
We don't know if it remained there, but
During this period, image analysis allows the series of events to be reconstituted piece by piece. After a 7-hour fall, Philae touched the surface of the comet at less than 10 meters from the targeted point. The calculations of the flight teams were proved to be perfect, as can be seen from the impact on the surface, visible on these images taken by Rosetta. But Philae's anchor harpoons failed to fire, and it rebounded away. This image, taken 10 minutes after the impact with the surface, is the last in which Philae is visible. The remainder of its trajectory is deduced from measurement instruments. The lander, with a weight equivalent to an object of about 1 gram on Earth, would have ascended to an altitude of over 1 kilometer. And at 7 p.m., Rosetta, having passed over to the other side of the comet, can no longer establish contact with the lander. There will be no news until 6 a.m. tomorrow morning, when Rosetta rises above the comet's horizon, before knowing if Philae has come to rest and is operational, or if it has disappeared. In the control room, after 10 years on mission, nobody knows if a world first has been achieved or if the adventure is over.
That's when you're sure you can see the...
That was the best moment you did. That was the best moment.
That's when you were sure you got rid of it.
Ist die Optimism krass.
Ja.
Stefan, du warst sowas von down heute Morgen.
When I came in this morning, very early, it was 6 o'clock Zulu, so 7 o'clock in the morning. We were here alone. No pressure, nobody else. And we saw the signal of the lander coming exactly spot on at the right time. We saw that the lander was alive. The thing was on the surface of the comet, survived on its own for more than 10 hours. I think the emotion I felt there was so deep into my heart that you can't imagine how it was.
13 November 2014 at 7 a.m. The images transmitted to Earth by Philae have finally arrived. One of its 3 feet, posed against this dark rock, this primitive matter, a witness to our origins.
탐사선 로제타와 필레의
300 years after Newton and the first calculation of comet orbits, a man-made machine has touched on the surface of a comet. The European Space Agency mission has hailed the world over as an exploit unprecedented since man first walked on the moon.
The true story, I think, is the Shiva panorama, because this is somewhat old. So we want to see how it is located.
But from the raw image of the Shiva panorama, because when you see the foot, the one published, there's a very black portion. Is it sky, that one, or we don't know yet? The stars? Yes.
Probably.
After 2 almost sleepless nights, the principal actors of the mission discover that they are at the center of world attention.
We are there.
You're not going to get to forget this one.
I was talking to Sylvain at that time. I wanted to
arrive here, so it's really
the
process. It's really the
So we have the first images taken by the orchid.
Jean-Pierre Bibring, Philae Scientific Director. Holger Sirks, Rosetta Camera's Director. Stefan Ulamek, Philae Operations Director. And Andrea Akamatsu, the pilot, get together to tell the world about the Rosetta adventure. Trapped in the shade of a cliff, Philae is unable to recharge its batteries as planned. Before they die in about 60 hours, a maximum of instruments are activated. 75% of the planned scientific data are transmitted to Earth, and a final command is sent. Philae's sonar panels are reoriented to optimize their exposure. The engineers hope that the small amount of energy accumulated from day to day will suffice to reactivate the machine before the programmed end of Rosetta's voyage in December 2015. But already following on the technical exploits, the revelations of the Rosetta mission are being reported by the most important international journals as major scientific advances. The data from the Rosetta probe that continue to arrive at the laboratories confirm the abundance and variety of complex organic molecules.
Radiation, so it should be quite the original material.
Until the Rosetta mission, mankind had never been so close to rationally explaining how matter is organized to give rise to life.
Ça, c'est vraiment l'évolution de l'univers. Tu pars d'un chaos et tu ordonnes au cours du temps.
A process that, as we gain an understanding, reveals a character that is both universal and exceptional.